And then we get into these multiple criteria things. And it's basically from people arguing that single criteria definitions have failed. We need multi-criteria. Now, by moving on to multi-criteria, it should be clear that this pseudoscience definition becomes much more fuzzy. It becomes much more difficult to delineate because now you're like, how many of the criteria does it need to meet and how closely to be actually considered pseudoscience? It's not an easy answer to this question, but maybe we shouldn't. And this is the people that are proposing multiple criteria. Maybe we shouldn't look for an easy answer. Maybe it's complicated. Maybe there are a lot of factors going on here. So here are a couple such criteria. One is sort of belief in authority. Basically, the people have some special ability to determine what is true or false. Unrepeatable experiments. Hand-picked examples. And let me say, too, the unrepeatable experiments part is the idea that, others can't repeat it, or it's something has happened and later attempts that have tried to repeat it, people are claiming, no, like trust us in the original experiment. Don't trust the people that have tried to reproduce the results and haven't been able to do it. Unwillingness to test, a disregard of refuting information, a built-in subterfuge, which is basically this would have been Popper's complaint with Freud's theory, which is basically it's arranged that it can only be confirmed, or you can always invent some explanation. It's not risky. It's not making any predictions that could falsify it. So it's not able to necessarily be refined. It's not looking to be refuted per se. And then, explanations are abandoned without replacement, which is basically like you kind of give up some of these explanations and you're rather than refine and improve them, you're not really making any progress, and it just ends up leaving a lot of holes. I think that would be what's being said then. The next set would be Merton's norms. Now, Merton has these 4 criteria, and if it violates any of Merton's 4 norms, force good science, then it would basically be kind of considered pseudoscience. One is basically originality. If it's not basically presenting something new to the scientific community, although I guess this is a weird one because you could argue something like astrology or something is adding something new that hasn't been considered before. 2 would be detachment. This kind of goes into this other part that's a very common thread among a lot of these definitions, which is the idea of agenda. Are people trying to push a specific agenda more than do good research? And if that's the case, it's more likely to be pseudoscience. So the idea of detachment is, hey, it's kind of independent of my own personal beliefs. Even if my reason for testing and wanting to do this theory has personal or value judgments in it, my methodology for testing it or the theory itself should be relatively detached as possible. Universality, basically the idea is it shouldn't be restricted to some people that are claiming to have special access to truth. Anyone should, in theory, be able to reproduce this result. It shouldn't be dependent on that. Although, to the extent to which that's even a possible thing, given the amount of knowledge and the amount of expensive equipment people need to be able to reproduce experiments, I think this is a difficult one. I think, more needs to be said about that. And then skepticism, it's basically like one needs to really question and test things. You can't be just taking it based on faith or trust that the theory is true. If you're trying to refine, faith works great in relationships where you trust somebody's going to have your back, and this works well. But when it comes to a good scientific theory, you need to be able to make it risky. You need to actually test it and not be able to say, okay, well, we can trust this is good enough and we're done here. It's like, no, you need to actually keep going and revising it and looking at the data. And then lastly, I guess there was another one too. Public accessibility, basically communicating your results. This is part of the scientific method, and seeing if a committee of peers thinks this is good work and publishable, these sorts of things. Then we get to Hanson's criteria, and there are a few of these that I do kind of disagree with, but I do want to talk about them because Hansen is very big in philosophy of science. So one is cherry-picking data that supports a viewpoint. Obviously, this should be non-controversial if you're considering only views that confirm your belief, and kind of goes into number 2, neglect of refuting information. But if you're just cherry-picking data to tell a story, there's some idea that you're not doing actual science. You're instead trying to push a specific agenda. So once again, the neglect of refuting information would just be kind of similarly would be cherry picking data that supports your view and not engaging or just dismissing things that could challenge your view on the basis of things that have nothing to do with the research themselves. So maybe it's like, okay, these people, claiming other people have an agenda, would be an example of number 2, where you're not actually engaging with the arguments. You're instead just finding some way to avoid having to even consider them so that you're able to stake your own ideological position. One would be fabrication of fake controversies, conspiracy theories, hype claims about large groups being wrong. The main thing here, though, and this is subtle, is these controversies actually need to be made up, because there are cases in which somebody makes a theory. Most of the time, anytime somebody makes a new scientific theory that contradicts a lot of commonly held research, there's going to be controversy. And I think maybe there even should be, because if something is contradicting these results, we need to actually test and make sure that this is actually, what's going on, rather than just some provisional claim. But the main thing here is the fabrication, the fact that they're making the controversies and the controversies are fake, not that the controversies themselves exist. So I would qualify it there. Deviant criteria of assent is a good one. It's just basically saying, how would we know this is the case? If it's not through repeated testing and these sorts of things, saying like, okay, well, we shouldn't trust this theory because it's hard for the public to understand it. This is a different criteria of determining whether or not a theory is good beyond just letting the data speak for itself, doing more experiments, doing actual good research into it, these sorts of things. So when people are claiming that you can know this to be the case by some other means, we should be skeptical if this is actual science. And then Hansen lists these 10 sociological criteria, and these are the ones that are actually, I think, some of these should be controversial or are going to be controversial, but it's at least good to know what these are and get a feel for what Hansen's saying. One would be the focal theory threatens the denialist's worldview. This would basically be like pseudoscience is the kind of thing where you can tell it's pseudoscience because it's very clear that people are doing this. Now, Hansen gives the definition in terms of, okay, creation or evolution contradicts people who are creationists' viewpoint, so they dismiss this evidence because they have this presupposed worldview about it. And it's interesting because this argument kind of goes both ways too. You could argue, say if there's evidence for intelligent design or anything like that, it's going to cause someone who's a naturalist or an atheist to it's going to challenge their own worldview. So once again, when people are putting theories or putting responses or challenges because they're trying to protect their own ideological position, regardless of where it is, I think Hansen is saying you should be skeptical of them and potentially classify them as pseudoscience. The next is kind of similarly complaints that the theory that's being questioned is too difficult to understand. So the one that's there, basically it'd be pseudoscience if you're, or more likely to be pseudoscience, I should say, because this is multi-criterion, basically saying, okay, the prevailing theory is too difficult to understand, trust us on this, we have a better theory. Once again, ease of understanding isn't always the best way to pick between theories that are true. Although in many cases, I think that's a difficult thing. That's a difficult thing, but it shouldn't be the only thing. Let's put it that way. If theories that are easier to understand fit the data better, then that's what it is. But really, it's because it fits the data better. Another one would be lack of expertise among the people that are claiming the theory. Yeah, this is a big deal, right? If people aren't even able to engage or are unwilling to engage with the arguments for the theory, or they don't have any reason, I mean, it doesn't mean it's necessarily false, but if nobody has relevant expertise in this area of study, you should be skeptical that the theories put forth are a good representation of what's kind of going on. And potentially, it's more likely to be pseudoscience if people who haven't studied this stuff or haven't done good work on this stuff are claiming they have some new way of looking at it. Now, it's interesting. He says a lack of diversity, and the example he gives is a strong predominance of men among denialists. And I kind of agree with him, but I think it's weird that he focuses on men, because you could argue, okay, well, look at the field of electrical engineering or something. It's like 10% women. Does that mean we should think that electrical engineering is pseudoscience or something? I think what would make a stronger case in Hansen's case is a sort of lack of viewpoint diversity. So it's like the idea that this is more, that the pseudoscientific enterprise is going to try to quash dissent, and it's very clear that they're only like restricting themselves to people that agree. So then it becomes clear that they're trying to do this with a certain ideological position. If they're trying to squash discussion or relevant challenges, we should be very skeptical that they're actually following good methodology in their theories. Next is the inability to publish in peer-reviewed journals. Although my rebuttal to this would basically be, look, they can make their own journals. And they can claim that their journals are peer-reviewed by the peers that they have in their particular thing. So I don't know if this is necessarily a good enough criteria. I understand what he's saying is like, if people aren't able to publish their work, and we trust that, a committee of experts should be able to, like, if the scientific enterprise is working the way it should, then if people aren't getting their papers published in these journals, we should be skeptical that their results, if they're not able to convince experts in this area, we should at least be skeptical that these are real scientific results. But of course, what people can claim that are doing potentially pseudoscience is that, hey, the editors of these journals are biased or whatever, or they're unwilling to look at this, and or maybe even, okay, our results aren't the kind of thing that we would expect to be published in these particular journals, not because our work is bad or follows a flawed methodology, but because it's outside the scope of this journal, or it's off topic. So you need to be very careful with number 5, because there could be other nuances going on here, because there's a lot more going on than it's not that journals have these great perfect reviewers and experts that are always willing to accept the best papers or the most true papers. This is an abstraction we use, but it's sometimes not always the case. And this has been a common complaint now among a lot of current researchers. It's just the quality of the review process, the reproducibility crisis, all these sorts of things, basically cause researchers to distrust the ability of peer-reviewed journals to communicate or distinguish science from pseudoscience, these sorts of things. Another big one, huge one, a tendency to embrace conspiracy theories. I think this should make sense. Hey, look, we are all being persecuted by all of these people, and people don't want to listen to us because of this and this reason, or the government is trying to keep us from publishing this result because it, or like, aliens exist and there's this big conspiracy to hide aliens in the government. These sorts of things, I think, are more likely to be pseudoscience, or more likely to be an indicator of pseudoscience. Although, if the conspiracy theory is true, then it's not necessarily false. But once again, you can kind of get these patterns or see these patterns from these criteria. Appeals directly to the public. This is a tough one, but I think the idea is, if you're unable to talk with the experts or the people who are considered the best in their field, and you're going to the public, you're not able to publish your results, you should be very skeptical of the people. They're like, why aren't you publishing these results in journals, or why aren't you taking these issues, especially if nobody there is an actual researcher or something, and it's like this realm that's ignoring the experts and the people that study this. It's kind of shows like a disrespect for maybe the field itself that the people are claiming to do, or disrespect for science. If you're claiming what you're doing is science, but you're like not engaging with scientists and talking with them and doing this, it shows that maybe a lack of respect or a lack of ability to engage on these matters. The pretense of having support among scientists. So, this is another one saying, look, everyone shares our view. This is obviously the case that this is, maybe a theory that's in crisis or something, and everyone agrees with it. Be very careful with this because, first of all, it's difficult to get these reports of what scientists actually believe. But just I guess be aware if they're resting their case on, okay, well, most scientists agree with this. Well, most scientists have agreed on a lot of things that have been wrong in the past. So you need to look at the evidence for itself. And another huge one, pattern of attacks against legitimate scientists. Now, I'd argue these would especially be indicative if these are ad hominem attacks. Like, they're not even looking at their work. It'd be saying like, this person is a liar, or this person is, is like this race or this gender or whatever, and that's why we shouldn't consider their viewpoints. I think that's very clear that whatever the theory is, that's how they deflect attacks. This would be more likely to be pseudoscience. And then, lastly, strong political overtones, once again showing that potentially they would have some other agenda besides the impartial search for truth, or as impartial as possible.